Now, linear regression is all about fitting a straight line across data. So, going by our previous example, if this is, let's say, the area, and if this is the price, we will have a bunch of data points like this, the crosses. So, for area of these many square feet, I will have the corresponding price to be this, whatever the value is on this axis. So, in order to build this, first of all, we need to understand something called squared errors. So, whenever we predict, we will always be making mistakes. We can't be 100% accurate all the time. So, this is not fortune telling. It's a statistics-based reasonable estimate of what a house price can be based on areas. So, we'll have errors. Now, one way to measure error, as dictated by the squared errors concept, will be I take my predicted value and I subtract it from my actual value and then I square it up. So if the price of a house is 100 and I predict it will be 90, then the squared errors will be 100 minus 90 squared, which will be equal to 10 squared, which is nothing but 100. Okay, so if I predict a house price to be, let's say, 87, and it turns out to be that the original price was 91, then the squared errors will be 91 minus 87 squared, 4 squared, which is 16. And we do it across all data points. For each data, we will have to measure basically this distance. So this will be our predicted value at this point for this area, and this cross will be our actual value. So whatever the distance between these 2 points will be my errors. And in matrix notation, since y is our dependent variable vector and x theta will be our predictions, we just take the subtraction, and for taking squares, what we do is we multiply by its transpose, minus x theta. So if we do this, it's something like, so let's say I want to calculate 10 square and I want to calculate 8 square, and I have a 10, 8 vector with me. If I multiply it by its transpose, so transposing is just reversing rows and columns. So if I have one row over here and 2 columns, I will rewrite this across 2 rows and only 1 column, just like that. So now if I multiply them, what do I get? 10 times 10, 10 squared, plus 8 times 8, 8 squared. So again, y minus x theta transpose cross y minus x theta is a sleek representation of the summation of all the errors that we have made. So if we measure error over here, add it to this, add it to this, and then add it to this, and do this for all points, we will end up getting the same thing as we did in case of here. So in linear regression, we try to build this straight line, and whatever errors that we make, this is how we measure them with the help of squared errors. Now our objective will be to minimize these errors, right? So if I can make sure I keep my errors minimum, I can come up with the best straight line that I can fit over here. Okay, so here we will use some linear programming concepts. It says if the derivative of the error term with respect to theta is set to 0, we are in business. In the further reading section, there will be more details on why this is the case. So for anyone who is interested in knowing further, we will provide the right materials. So a way to compute theta will be to set
d d theta of this error term to be equal to 0. In the next video, we will try computing this to derive our theta.